Explain the structures of diborane and boric acid. Wow. Let's take a look first. Diborane. Diborane is typically B2H6. B2H6 contains 2 bonds of boron and 4 bonds of hydrogen. All these 6 atoms are in one plane. And the most striking are the bridging bonds. There are 2 bonds of hydrogen. What? Hydrogen is forming 2 bonds? What nonsense is this? That means, is hydrogen expanding its duplet? No. That is the strangest activity actually. What happens is that if, say, this boron has a BH bond, then electron of this BH bond is also attracted by the other boron atom like this. What you get is the so-called 3-center 2-electron bonds. What does it mean? There are only 2 electrons in a BH bond, but those 2 electrons are also pulled on this side. So it's 1, 2, 3. It's a 3-center 2-electron bond. Oh my God. And this is in a plane perpendicular to the other plane. Okay. So there is one bond like this and there is another bond like this. Oh wow. Wonderful. They look like bananas. Yeah. And that is why sometimes people even call them banana bonds. I'll just draw them back for you. Like this, you can draw them. These are called bridging hydrogens. And these are called terminal hydrogens. So overall, you would see that this is this BH inside. It is a perpendicular plane. So this is the way you should be able to view overall structure of diborane. 2 mutually perpendicular planes, 4 normal BH bonds, and terminal bonds are stronger bonds and shorter. These bonds are stronger and shorter. These are longer and weaker. Why? They are weaker because bond order is only half. This is a full bond. This is half, 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 half. That is the way you should count them. This, my dears, is the structure of diborane. This bond angle HBH, terminal HBH bond angle is close to 120 degrees and bridging HBH angle is close to 90 degrees. Now let's talk about boric acid. What is boric acid? Boric acid, also called orthoboric acid, is H3BO3. It has boron, it has O, O and O, it has H, H and H. Lone pairs like this. And it might appear that this could be a zigzag molecule, but no. Boric acid is trigonal planar around boron. And also please note, the funny part of boric acid is that each of these oxygen atoms contains these lone pairs. There are lone pairs you can see. So one lone pair on each O atom undergoes P-pi back bonding with boron atom. Oh my God, is that so? Yes, it forms P-pi back bonding with boron atom. And because of this, my dears, this, not only this is planar, because of this, oxygens also become sp2 hybridized and the entire boric acid molecule is perfectly a planar molecule. So O atoms are also sp2 hybrid and all planar molecule. This, my dear, is the structure of boric acid.